Hello everyone, I'm Vembu. Welcome to my channel. So in this video we are going to talk about an introduction to Kubernetes. This is for absolute beginners in terms of Kubernetes. You may have some experience in IT industries. You don't know what is Kubernetes. You wanted to know why we need Kubernetes and why why it's the buzz of the town these days. So these are the topics we are going to discuss. So if you're not a beginner, if you have some experience in Kubernetes and if you wanted to learn more deep topics in Kubernetes, I will be uploading videos in the coming weeks explaining more about Kubernetes and DevOps as a whole. Stay tuned for that. But back to the agenda, we have introduction. I'm sorry. So I will be giving a brief introduction about me. And then we have VM based monolith. I will be explaining you both server and a VM based monolith of a simple environment. I will be explaining it to you with pictures and what are the problems we will face when we are using a VM based environment. Then what are the advantages of using a containerized environment. I will explain about the architecture of the container environment. Then again the problems with the container environment. Then finally why we need Kubernetes and how the Kubernetes architecture works. So that's the last topic that we are going to discuss. So let's move on. Before going to monoliths, about me, I'm Vembu. I've been working in IT industry for about 10 years now. So the first 4 years is into system administration, and the last 6 years I'm working in DevOps and platform engineering. Right now I'm working for a multinational or an international bank, managing an application which has about 6 to 7 million users, active users, handling transactions in different mediums. I don't want to share much information about my work related environment, but that's about me. So let's move on to the topic. So what is monoliths? You might have heard the term monolith versus microservice. Monolith is nothing but an application entirely running on a single server. Again, microservices, you will be splitting that application into multiple components or containers, then you will be running it in a containerized environment. So we will talk about it in depth in the coming slides. So I want you to imagine a pizza store near your home, so that has few employees and few stores around the city you are living in, probably 20 to 50 stores. And then how their infrastructure, their backend infrastructure is managed. We are going to talk about that, and as they grow along from a single city to a state to a different to the entire country and to become an international chain, how we are going to upgrade their backend capacities so they can accommodate more and more users and much higher loads. So this is, I'm gonna start with a very basic thing. So this is a server based monolith. So as you can see, this is an employee store devices, which is the monitors you see in the cash counters where the employee is pressing different buttons when they're taking your order. And then the next one is user based mobile apps. So the users will be using this kind of mobile apps. You and me will be using it to place the order. So I'm going to treat both of them as an external entity. They will be going through firewall. Again, as I said, this is just for representational purpose. This is not an actual picture of how an architecture will work, and this is not a recommendation as well. So it's just a simplified version of so that you can understand the stuffs easily. And again, coming back to the topic, this is UI. We will be hosting it in two different servers, front-end servers we call them. From the front-end servers, we'll be forwarding the traffic to the load balancers. Again, the load balancers will be doing it or sending it to the backend cluster, which will be hosting the application on multiple servers. It will receive it and then it will send to the database, and back and forth the communication happens. So this is how an architecture works, but there is some problems with it. So even though you have an application running, if you want to scale it from 50 store to 100 store, you will have to buy all these hardware devices, which is not recommended. Okay, so because you are dependent on a lot of things, you have to take orders from give orders to your vendors, and then procure the equipments, make sure that they are compliant, and all these things are there. And then you have to increase your storage space. When I'm talking about storage space, I'm talking about the physical storage where you're running your data centers, so you'll have to increase that as well. That comes with a lot of other complications like the electricity, power, how you're managing stuff, this, that, and all. So that will be one set of problem. This is, you can't scale whenever you want it, whenever you like it. The cost will be higher because you are going to be managing almost everything. And then when it comes to disaster and all, if you're managing it in an VM, it will be very easy for you to recover. I'm not saying you can't recover physical servers. You can do that if you have proper backups. But if you're using a VM, that will be a much easier and a simpler process. So that's the reason we would need a VM. And this is a VM based architecture. So I didn't change anything here apart from the physical servers being moved to, let's consider them, we migrated that physical servers into virtual machines. So instead of 2 front-end servers, we have 2 virtual servers now, and a scale set of VM that will be hosting the backend, and then SQL DB. So nothing else changed, it's just VM. So what's the problem now? So I know I explained about the problems we will be facing when we are using in physical environment. Now that we've moved to virtual machine, you have a lot more flexibility, the cost is reduced, you can scale whenever you want. Then why do we need VMs? Why do we need containers, which is the next stage of VMs? So we have to understand why and how Docker works, so you can take a better decision whichever suits your application. So usually any application, whether it's any server, I would say application, okay, let's say a server that is running, it can be a physical server or it can be a virtual server. So it will have 3 different layers. The first one is hardware. On top of it you will have the first layer, which is OS kernel, and then you will have the applications layer. So I'm not talking about the OSI layers here, it's just for representational purpose. So on top of hardware you have OS, and then you have applications. So that's the standard way of doing it. So that's how the container works. So what a VM does is, when you install an hypervisor on top of a hardware, it virtualizes a OS for you. So that means if you're using a physical server, you will be having one physical server. On top of it you can install only one machine, one OS. That basically considered as a single server. But if you're installing an hypervisor on top of the hardware, you can install 5 to 10 servers. I mean, I'm just giving random numbers. You can start with 2 servers going up to 10-20 servers depending on the size and capacity of the hardware underneath. So the OS, you have different OS. You can have 2 Windows, 2 Linux, whatever it is. So coming back to Docker, you will have hardware. On top of it you need a OS, whether it's a Windows or a Linux, and then Docker will comes into the picture. So the Docker doesn't have a kernel of its own. It will be using the kernel of the existing operating system that is running underneath. Okay, so that's the basic difference. It may seem like VM is a much better option when compared to Docker, because Docker only does application, you still have to install OS. That's not the case. I will come back, I will explain it to you in detail. So the reason Docker container or any other container is better than a VM is because you don't need everything, the size. So when you want an application, let's say that application is about 10 to 15 GB in size, and it usually it doesn't take that much space. Let's say that 1 or 2 GB in size, it takes about 2 gigs of RAM, all this stuff. So you're just going to run only one application in that server. In that case, you have to have an entire set of hardware, and top of that you will have OS, and then you will be running the application in it. So there is not much beneficial in doing this way, I would say. The reason being, your OS will take off of your space, at least off. Nowadays I'm seeing it a lot. I'm using an VDI, which that VDI itself takes about 50% of my memory. It has 16 GB. 8 GB was utilized almost all the time by the VDI. I'm only left with the remaining 8 GBs. But if you're doing it via Docker, Docker is like a very compact version. If a VM is about you know if 10-20 GB, Docker will be in MBs. And again, that's the resource efficiency. When you have very less or very little file, the application will start up very easily, and you can port it from one environment to another environment very easily. For example, if you develop it in one computer in dev environment, and if you move it, you will be containerizing it and moving it, so it works almost the same as how it worked in the development environment. I didn't include other dependencies and stuff, just the container. It's very easy and very portable, because you're not moving as an entire application or server. You just pack it up in a single container and then you just toss it across to another environment. So isolation and security, I wouldn't say this is a much I wouldn't say it's a complete advantage. You can isolate it, but again it will be connected with other containers. But in terms of security, your size is very less when you compare to VM. So VM is have about 10 GB, as I said. So this containers will have about 100 GBs, probably less than that. So I mean, if you have a very narrow space to hit for the hackers, because you don't have 10 GB, you don't have unwanted data, you don't have Windows files, Linux files, it's just the containers and the application file. So the attack surface is reduced, and it's consistent across the environments. As I said, portability is another point of consistent across environments. And if you are planning for DevOps environments, or if you're already in DevOps environments, using containers is a much better option to leverage the full capabilities of a DevOps environment. You can automate everything, starting from committing your codes in Git till deploying it in a production environment. Everything can be automated if you're using Docker. So we have looked at our monolith application, right? So I want you to, or let's say we will be doing it together. We have migrated from a physical server to virtual server. Now we will be migrating this virtual servers into a containers. So how are we going to do that? So this slide, I just used it to separate or segregate different services, so we can create each container for each one of these services. Okay, I'm going to keep UI as a separate entity. It's still going to be running in a same server. I just put two different boxes for your understanding. UI will be a single service, and probably we can say menu and pricing, the orders you placed, customer info, and then the pricing calculations. If you have any commands to kitchen, you can do that. Order generation, bill generation, and finally the payment. So I highlighted order generation and bill generation. I will explain about it in the next few slides. And here I'm not containerizing, or I'm not converting a database into microservices. I'm going to keep it as a separate entity, okay, as a server. There is nothing going to be changed in terms of database. So this is how an environment looks like. It doesn't have to be in this particular order. It can be in any particular orders. That's how, I mean, that's the architects and the developers has to define it. So now we started with the physical server. From physical server we moved to virtual machines. From virtual machines, now we are at a stage where we containerized everything. It's running as containers in a single server. So why do we need Kubernetes in this place? Because now we have everything in containers. It's much more flexible now. The reason I included order generated and bill generator is because here these two things are separate containers. Okay, consider them. So this is order generation as a single container and build generation as a separate container. So even though we have them as containerized environment, there are still certain capabilities that we are not using it to its full potential, like managing and stuff. So that's the reason we need Kubernetes. You don't have to schedule or manage your pods. If you're talking about 10 pods, it's okay, you can manage it. Let's talk about 10,000 pods. So for an company that is companies like Amazon and Google, they run their architecture in microservices. They will not be running it in 10 or 20 pods. So it will be in thousands and thousands and thousands. So in that kind of environments, it's very easy. It's not that easy to manage manually. So it has to be automated, scheduled. It has to be automatically managed. The scalability has to be very easy and very reliable. When you're scaling it, it shouldn't go down and stuff. You should have options to manage it, and self-healing capabilities. There is something called replica sets and all in Kubernetes. So if you set it to 2, even if 2 pods or 2 containers, even one fails, Kubernetes will automatically recreate another one within a matter of seconds. And load balancing and service discovery, these things are inbuiltly available in Kubernetes. So you don't have to enable them separately. You will be doing it in a larger environment. You will have a lot of load balances, but it has its own things. So you don't have to worry about the pods running inside the Kubernetes. You will have to worry about how to connect to Kubernetes, but once it reaches Kubernetes has its own capabilities to manage the stuffs that's running inside it. And again, DR, so it's a disaster recovery. It's kind of much simpler than a traditional environment. So these are some of the advantages of using Kubernetes. I wouldn't say this is all of the advantages, but there are a lot more. Kubernetes is like a mountain, and this is just like a small stone I'm putting in this slide. So this is how a containerized architecture in Kubernetes will look like. So earlier we looked at it from container, which is just running the stuffs in container again. But even though this is running in container, this is still a server. Okay, we are running the application as a containers, but the server is the same thing. But again, the same set of problems come here as well. If you want to if you want to have another set of the same thing, you will have to buy another set of servers and do it. The same problems, right? So that's why we moved to Kubernetes. Before I explain about the architecture, this order and build generated, you may have noticed, and I mentioned it as well. So this thing is running as 2 different containers, but here it's running as a single container. So order and build generation is not that different. It can be done. It's kind of an independent. It's not independent. It's dependable on each other. Okay. So there is a concept called pod, because now I'm talking about pods, because before this slide everything was containers and VMs. So what is the difference between container and a pod? It's almost the same thing, but there is simple differences. So container is a service that is been containerized. You will be probably writing a Docker file and containerize it, and then Docker will create a container for it. What is a pod then? So the pod in terms of Kubernetes is the smallest unit that runs the containers. So menu and pricing is a container and a pod. Okay, orders, it's a container running inside a pod. So if you look at order and build generator, this is a single pod, but this pod has 2 containers inside it, which is order generator and build generator. So what I'm trying to say here is a single pod can run 2 containers, or it can run 1 container. Okay, usually it will be only 1 container, but in certain cases there will be 2 containers running inside a pod. So that's the only difference. So it's the basic term you should understand. That's why I explained it in detail. So this is a Kubernetes cluster. So you have a master node and you have a worker node. You have 2 different worker nodes and you have database. So the master node is like a control plane from where you manage the entire Kubernetes cluster. So, and the worker node is where your application runs as the server, okay? And this is where the magic of Kubernetes happens in master node. So you have 4 different components in master node. You have API servers, controller, scheduler, and etc. So API server, it kind of acts as a gateway or a gatekeeper. It manages the authentication and authorization, and then you have controller. It's like it manages the state of the application. As I said, it has self-healing capabilities. Let's assume that this order pod got crashed. The controller will immediately monitors it, and then it will reschedules it. So scheduler, again, this is a different service in master. So its responsibility is to schedule pods. So when controller detects that the order pod is down, it sends instruction to scheduler, and then scheduler schedules it, and then scheduler will update the record to it said that this was deleted and I recreated it. So etcd is like a database where it keeps all the records of Kubernetes. And worker node, it has 3 different components: kubelet, kubeproxy, and container runtime. Kubelet is responsible for communication between the master node and worker node. So again, coming back to the same scenario, orders is crashed, controller detects it, sends instructions to scheduler, and scheduler sends instructions to kubelet, and then kubelet do these things. It reschedules the pods. Okay, and kubeproxy is like it manages the IPs and stuff. It's like the network related thing, because pods are ephemeral. Okay, pods tend to restart a lot, and we can't so the pod IPs will not be a stable one. This hour you will have one IP, in the next hour there will be another IP. So what kubeproxy does is, kubeproxy have a routing table that has all the IPs of the pods, and then when someone reaches, they will be reaching through the node IP. Kubernetes networking is a big topic. It has services like load balancers, node port, cluster IP, and all those stuff. This is a very basic thing. I'm not going to dive deep into this. That will be too much for you to digest. So you have another environment which is running the same set of these things, just a replica of it. Now you have 2 nodes. Now let's assume that we are in state level, okay, or we are like in a provincial level, where we have about 500 to 1000 stores now of that pizza place. Now it's moving to international, probably to a couple of more countries. So in that scenario, you don't have to create everything new again. You just go into master node, you just spin up our code, change the values in YAML to spin up one more worker node. That being said, you have to have a server or the resources available for that. If you have the resources or another server or another worker node, you can run it, or in the same worker node itself you can run. Let's assume you don't have more resources. Let's say that your resources are constrained, you can't procure another server, but again worker node 1 and 2 has access capability, so that has 32 gigs of RAM each of them, and you're only using 10. Okay, so in that case you will be running 2 sets of order, 2 sets of menu and pricing in the same worker nodes. That's how the Kubernetes works. So this is about how the architecture and the flow of DevOps works. I will be discussing about this in the coming lectures, but if you have any questions, you can let me know in the comment sections, or you can drop an email to me. This is my LinkedIn. Before we sign off, I want to look at this picture. This is the Death Star. You may have heard about it, or you may not. If not, you can Google it up. This is the microservices architecture of Amazon. I'm not sure whether the Death Star is official name or not. It looks like a Death Star to me. So probably that's the reason why they named it as Death Star. So you can look it up. All these blue and orange and green dots you're seeing, all of them are microservices combined together, running in Kubernetes in AWS environments, probably thousands of them. You can have white papers about this. There are some white papers about this. You can read about it. Okay, so that's that's the end of the video. I hope you enjoyed it. uh, Thanks a lot for watching. See you in the next one. Thank you.